Math Module 5, Lesson 10, here it comes, in 2 seconds. There we go. Alright, so a lot like yesterday, Lesson 9, pretty much similar to this one. You can see that they're regrouping the smaller pieces into larger pieces here with these large pieces on it. So let's look at the wording up here. It says, compose the shaded fractions into larger fractional units expressed to the equivalent fractions in a number sentence using division. The first one's been done for you. So this first one is just the way they want it done. 4 and 6. 4 and 6. Now they can both be divided by 2. Is there another number that could divide 4 and 6? No. The only one is they're both even. 2 can divide them. And that's what's going to put this back into its bigger pieces up here. 4, 6. 4 and 6 divided by 2 gives 2/3. Pretty simple. Let's look at this next one. Okay, like yesterday, think about that size. Yesterday, we had pretty simple fractions. This one's actually, if we count it up, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10, 11, 12. So it's 9 out of 12. Is there a number that can divide both 9 and 12? Well, in this case, 1, 2, 3 happens to work. 6 doesn't work, and 9 doesn't really go into it. So we can't divide 12 by, we can divide it by 3. So we can think, I could divide 9 over 12 by 3 and 3. Sometimes it takes a while to figure out which number is it that they want you to divide by, but it looks like they're both divisible by 3, because 3 times 3 is 9, so that's 3. And what times 3 is 12? 4. So 3/4. And you can actually see it here. 1, 2, 3 out of the 4th. Okay, so there's 1, 2, 3, and out of this 4th one here. 3 out of 4. Some of these are easy to just look at and say, oh, I know what that is. Like this one, it's going to be 1, 2, 3 out of 5. 3 out of 5, right? But the real fraction they want is to count up and say, well, this is actually 1, 2, 3, 4, 5, 6 out of 7, 8, 9, 10. 6 out of 10. 6 out of 10 is what's shown, but we can take that and we can divide the top and the bottom by a number. In this case, 1 won't do anything. 6 divided by 1 is 1. 10 divided by 1 is 10, so that wouldn't change it. So we want to pick 2. Okay, 2 works. Anything bigger? 3. 3 does not. 10 is only divisible by like 5 and 2. So let's go with 2. So divide by 2 on the top, divide by 2 on the bottom. Our fraction will be 6 divided by 2. Well, what times 2 is 6? 3 times 2 is 6. And what times 2 is 10? 5. So the division is 3/5. 6 divided by 2 equals 3. 10 divided by 2 equals 5. And there you have it. 1, 2, 3 out of 4 and 5. There's 5 big pieces. 3/5. Simple stuff. All right, this one here. 1, 2, 3, 4, 5, 6 out of 7, 8. So it's 6 out of 8. Divide the top and divide the bottom by the same number. It's a form of 1. It's going to be the number is either 10 over 10, 5 over 5, 7 over 7. It's going to be like dividing this number by 1. And if you divide any number by 1, 6 divided by 1, what times 1 is 6? It's going to be 6. So you haven't really changed the number when you divide it by 1, and you're not really changing the fraction when you divide it by a weird 1 that's a fraction. You're actually getting the same answer, but you're reducing it down to its pieces. It looks like it's going to be 3 out of 4. Let's see if 3 out of 4 is really the answer. 6 divided by 2 is 3, and 8 divided by 2 is 4. So it does work. 6/8 equals 3/4. The same amount. Compose the shaded fractions into a larger fraction units expressed the equivalent fraction in a number sentence using division. The same thing here. I'm not sure what this doesn't really change anything. 1, 2, 3, 4, 5, 6. So 4 out of 6. Divide the top. Divide the bottom by 2 over 2. Okay, they can be connected if you want to. 4 divided by 2, 2. 6 divided by 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 8 out of 12 equals divide it by, ooh, I bet we can get a number bigger than 2. Well, think about it. 8 is divisible by 2, 12 is divisible by 2. Is 8 divisible by 4? Yes. Is 12 divisible by 4? Yes. That's probably the bigger of the two. What times 4 is 8? 2. What times 4 is 12? 3. So 8 divided by 4 is 2. 12 divided by 4 is 3. Next page. All right. These, they want you to draw the area model to show this. Was it 1 times 4 tenths? And it could be the same thing as 2 fifths. All right. So tenths. 1, 2, 3, 4. There's fifths. Here's tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because I took the fifths and cut them in half and doubled to be tenths. So I need 4 of them. 1, 2, 3, 4. That's 4 tenths. Okay. Now I need to show that it's really equal to, and I can do the little drawing like this. 1, 2, 3, 4, 5. There's fifths, right? So actually it's also in fifths. And it's this one and this one out of fifths. So 2 fifths. So yes, I just represented that in a picture, that there's actually these 2 out of 5 as 2 fifths, which is the same as 1, 2, 3, 4 out of 10 pieces. Okay, easy enough. What about ninths? All right, ninths, that's interesting. How do I make ninths? Probably make thirds to begin with, because 3 times 3 times 3 is 9. So I'm going to go thirds. So 1, that's very bad, thirds. Sorry. You don't want like that. That looks better. Then if I cut it in half, I get sixths, but I want to cut it 1, 2. So I've got 3. It's a 3 by 3. 3 by 3. 3 times 3? 9 pieces there. Okay, so it's a 3 by 3. Now 6 ninths. 1, 2, 3, 4, 5, 6. Okay, those are the ninths. Looks like it's going to be 2 out of 3. Yeah. 1, 2 out of 3. 2 thirds. Don't worry about these things. I'm just using that as an area model to count 9. That's not a great drawing though. Sorry. Oh yeah, use division to rename each fraction. Below, draw it. Okay, draw it if it helps you. Okay, you could draw them if it helps. See if you can use the largest factor that's common to both of them. That means they share the factors. Okay, so like for 8 and 4. 8 and 12, 9 and 12. Well, 9 and 12, let's just take this one for example. Let's list the factors for 9. Of course, 1, that's really big. Yeah. So 9 is a factors of 1 times, of course, 9. Does 2 work? No. Does the 3 work? Yes, 3 times 3, and those are all the factors of 9. How about 12? We've done this before, so 1 works. Of course, 12 will work. 2 will go into it, actually 6 times. And then 3 will work, and that's 4 times. Okay, so the factors of 9 are 1, 3, and 9. Factors of 12 are 1, 2, 3, 4, 6, and 12. What's the biggest one they have in common? Well, the only one they have in common is this one right here, so the 3. Since it shows up in both of them as factors, we're going to divide them both by 3. And that should take us down fast. Okay? Okay, so 9 divided by 3 and 12 divided by 3, we got to attach that with a line, is going to give us 9 divided by 3. What times 3 is 9? 3. And what times 3 is 12? 4. 3/4. We found the biggest one that will go into it. All right. On the exit ticket, I'm going to take this exit ticket and I'm going to take a look at some extra ones here. We're going to imagine that we have 24 80ths. That's a crazy fraction. Can we reduce this fraction down? Yeah, there's some numbers that will divide 80 and 24. I think they're divisible by 8. Let's see if that gets us as the lowest terms. 24. So what times 8 is 24? Well, I believe it's 3. And what times 8 is 80? I believe that is 10. So it's actually 3 out of 10. So this fraction and this fraction are the same size. They're equal. 24 divided by 8 is 3. 80 divided by 8 is 10. As long as you use the same number, top and bottom, you will reduce the fraction down. What about something big like 13 24ths? It kind of looks kind of big. Is there any number that will divide 13? Well, 13 is a prime number, so only 13. Well, 13 divided by 13. Will 13 divided... Is 24 divided by 13? No. This actually is in lowest terms. You can't reduce 13 24ths down. Sometimes it just looks like they're big, and they can't become any smaller. 13 out of 24 is its own fraction. It's a strange fraction, but it stays 13 out of 24. So if you have 24 kids in a class, 13 of them are girls, that's 13 out of 24. So this is the fraction of how many people in class would be girls. Can you reduce it down? Like, can you pair them up in a different way? No. This is the fraction that has to stay. Okay? This is the worksheet that we're going to try today for an exit ticket instead. It's just go ahead and simplify these fractions. So we look at these fractions and we have to reduce these down to lowest terms. There's a number that they share that could divide them both. Like 2 and 16 share a number. 6 and 4 share a number. 10 and 12 share a division. If they're even, if they're both even top and bottom, not this one, but if they're even, we know they're both divisible by 2. Let's try this one here together before you get started. 2 divided by 2 over 2. 2 divided by 2 is 1. 16 divided by 2, what times 2 is 16? 8. And you can reduce your fraction down. All of these can be reduced in some way, using 2, sometimes using 3. I think 2 and 3 work a lot of the times. 2 and 3, 3 and 2, 2 and 3. Anything bigger than that? No, 2 and 3. So the only ones we have really are divisible by 2 or 3 and should be able to get your answers really quickly. Go ahead and work on that, and when you're done, just raise your hand and we'll go over the answers.